So let's take a gander at the enrichment from yesterday. And this challenge is thinking a little bit about the different types of numbers that we're dealing with. So in reading number 1, a subset of a real number is closed under addition if for any two numbers, A and B, that are members of the set. So for example, odd plus odd, or even plus even, or negatives plus negatives. Any subset that you can create. So if when you add those together, you get a negative number. So negative plus negative gives me a negative. Then we would say it's closed. Tell whether each of the following subsets of a real number is closed under addition. And if not, let's give a counterexample. So let's look at the first one, the set of whole numbers. So what we do is just test a few things. 3 plus 5, those are whole numbers. Oh look, it gives me a whole number. Let me throw it off. 0 plus 1 gives me 1. Let me try a big number, 100 plus 100. Oh, that gives me 200. It's still a whole number. The answer, it's closed. Why? Because whenever you add a whole number plus a whole number, you always get a whole number. All right. B, the set of negative integers. So negative 3 plus negative 8, negative 11. Okay? Negative, I can't choose 0, I can't choose positives because it only says negatives. So negative 100 plus a negative 100. Oh, look, I get negative 200. Notice the pattern. Negative plus negative is negative. Negative plus negative is negative. So we call that closed. A human giving birth to a human. That's a closed situation. The set of irrational numbers. So let's see. What if I had pi and I added it to pi? How many pi's do I have? 2 of them. And notice that 2 pi is irrational. Radical 3 plus radical 3 equals 2 radical 3. Yes, closed. Because an irrational plus an irrational gives me just more irrational. Okay? Which is true in life. You all know that guy, that person who's just crazy. And you give them a friend that's crazy, it's just nonstop crazy. The set of rational numbers. The set of rational numbers. So take, for example, 3.2 plus 3.6. And notice here that I get try that again. I get 6.8. So rational plus rational gives me a rational. 1/3 plus 4/3 gives me 5/3. Now notice I could do this. 1/3 plus 2/3 gives me 1. Is 1 a rational number? And the answer is yes, it's rational. Because it's also a whole, it's also an integer, and it's also a natural. But it's inside the world of rational. So rational plus rational is rational. So this is also closed. So notice for every single one of these, under addition, all of these subsets are closed. Let's take a gander here. For each of the sets in problem 1, let's see if it's closed under multiplication. So let's look at the irrational numbers. I'm going to do letter C right now. What is radical 2 times radical 2? Those are both irrational. I get the square root of 4, which is 2. So do I go from irrational times irrational and stay irrational? Nope. So this one under C is not closed. Because sometimes the product of irrational will give me rational numbers. The set of rational numbers, the set of negative numbers. So let's do B. What about negatives when you multiply them together? Negative 3 times negative 8. Positive 24, not closed. Because negative times negative gives me a positive. Brings me into the world of not negatives. If we look up here, it should take them 2.44 hours to climb up. 2.44 hours. I do need to see the work there.